With an area of a triangle, we've always used the 1/2 base times height, right? That's for right angles or angles that you always had to figure through in geometry. Now what you're looking at, in the case of what we're talking about for this whole unit, which is oblique triangles, which again, oblique triangles is all triangles that has 3 different sides and they don't have a right angle. Okay? So when we're looking at it, we say, okay, well, when you're looking at oblique triangles and you're given this scenario here, side, angle, side, and notice that the angle is in between the 2 sides. So you have 2 sides and the angle in between them. You can use this formula right here, and yes, it'll be given to you on the test and quiz, okay? So all as simple as, hey, write out the triangle, fill it in, and then use the equation to find the area. That's all. Some cases might be if you're missing an angle, but then you can easily solve it. So number 1, best case scenario. Easy case scenario is number 1. Number 1 is pencil. It says we have side, angle, side if we were to go around this triangle. So in that case, we can use the area is equal to 1/2. In this case will be 11 times 9 times the sine of 106. If you don't have a calculator, guys, go ahead and grab one, please. We'll be using it quite often today. If you don't have a calculator, go ahead and grab one, please.
Will we only get the formula for that one?
No, you'll have the formula chart, which will give you a formula of all of them. They'll even give you the ratio. Yeah, you bet. See, yeah. Let me print one out. All right, give it a few minutes, Tanner, and I'll get it out to you, okay, Ben? All right. I'll get it out to you, Tanner. All right, so as you can see here, we have our angle side angle. And if you go ahead and finish this off, so the sine of 106. And make sure your calculator's in what mode, guys? Degree. Degree is right. So you get the area is equal to 47.58 units squared. Like I said, best case scenario is they give you side angle side, plug in the formula, and you're done. All right. So let's move on to the next example. So Ms. Trigg has a triangle-shaped garden in her backyard. How much land does Ms. Trigg have for planting tomatoes? So again, let's figure out the case. It's exactly what we've had earlier. So area is equal to 1/2 24, 18, sine of 80. Let the calculator do the work. And so you end up with an area of... And so here's a question that rose up and said, you know, are we rounding to 2? Are we truncating to 2? What's the deal here? I really don't care. If you are 1/100th of a point off, it doesn't bother me one bit. As long as you get all the rest of the numbers right, I'm good with that. If you truncate or around, I don't care. Okay, as long as you get somewhere close to that. And the threshold is 1/100th of a point. Now, if you get 212.87, something's wrong. That's incorrect. But if you come over here and get 212.71, that's okay. You follow me on that? So don't worry about the rounding or truncating. Just get an answer and go to 2 decimal places. And whether you round from there or truncate, I don't care. All right, so that's it for area. So like I said, pretty quick. It's done. Make sure you say, okay, if I need to find the area. Now, it's nice to know that because you only have one scenario right now. side, angle, side, use the law of sine, and you're done. Okay? Now, when we go into cosines, it's going to look at something different. Okay? And we'll get into that when we get into that. But for now, we'll move on for this. Okay? So, guys, go ahead. In the warm-up, let's go ahead and work through those guys. There are, 3 problems? I'm going to go ahead and do roll real quick. All right? So let's go ahead and look at, so there's your warm-up. So let's go ahead and look at law of cosines now. What does the equation look like? So first thing, same thing we did with law of sines. Go ahead and label our angles and what they are. So we'll go through and do angle A, B, C, side B, side C, side A. Angle A is 47 degrees. Side B is 10. And C is 15. So here we go. What type of information is given to us? What case do we have here? Side, angle, side. Exactly right. It doesn't ask for it, but I want to go ahead. Well, actually, it says it right there, doesn't it? Pretty convenient. So we go ahead now and plug in everything that's given to us to solve this triangle. Now remember, we're solving this triangle, which means how many unknowns do we have? 3. We are solving for 3 unknowns. Well, here's the deal is we could figure out, knowing law of cosines, if you know side, angle, side, you'll be able to use the formula to figure out what the side, angle, side, whatever it opens up to, that is what law of cosines is going to help you find. Pretty much everything, what it all creates, what it all opens up to, that A is what we're going to find. So we come over here and we plug everything into the equation. And we say, okay, A squared, well, that's the unknown, is equal to 10 squared plus 15 squared minus 2, 10 times 15, cosine of the angle in between those 2 sides, which is 47 degrees. And as you can see, guys, we are set up here for one of the problems we did in the warm-up. We have to figure out what this side is. And like I said, this is best case scenario. Best case scenario here. Let's go ahead, type everything into the calculator on the right side. Cosine of 47. And I'm just going to go ahead and write this. You get 120.4. Please follow along in your calculator, guys, to make sure you're getting the same thing. I don't want you to get problems wrong because you have a typo in the calculator. That sucks. My old computer job, that's called an ID10T problem. Anybody heard an ID10T? ID10T. Anybody heard of that problem? An ID10T problem. So make sure we don't do any ID10T problems, okay? You didn't get 120.4?
I got 1 or 2. I mean, I got 2. And then I converted it to -2, and then it was just 1 or 2.
So you did 10 squared. Alright, so once you take the square root, so I'll just do second square root. Thank goodness for copy and paste. If you do it correctly. And you end up with A is equal to 10.97. So that's A. So we have A. What do you think we're going to have to do now in order to figure out angle B and angle C? We'll go back to what we've already done. We go back to what we already done, which is perfect law of sines. So by completing A, we've made up our what's called a reference ratio. A reference angle is going to be that side A and angle A together. So we set that up. Then we go ahead. We always recommend on this one finding the smallest angle first. And so let's go ahead and figure out what angle B is. Does not make a difference though, guys. It really doesn't. Bless you. Cross multiply. Sim sine. And then divide, right? And so what you see now is this goes away. Once we do the inverse sine of this, we will get what our angle B is. So a second sine. Guys, if you're not using alpha y equals, I highly recommend it. I got you going. You're welcome. All right, so we've got, what, 41.81 is angle B. What do you think we do to find the last one? There you go. You can add them up, subtract from 180, or just take 180 and subtract it from both of them. Same thing, right? And you end up with and that's it. The good thing about law of cosines, now there are work involved, of course, as you can see, like all of them will be, solving triangles. The good news is no ambiguous case, no special circumstances, no nothing. It is straightforward. Here you go. That's it. So with that being said, there you go. Now, again, this is the best case scenario. They gave us side angle side, which is great because when you plug it into the equation, everything on the right side of the equation is all filled in for you. So it's a simple, let the calculator do the work, you take the square root of it, and you're done. Very good? Okay. Now let's look at a little bit more work. It's not a lot, but just a little bit more. The scenario here is, as they already said, what if they gave you all lengths of sides, and you've got to figure out all the angles? So, A, B, C. They've given you 10, 7, and 6. Just for fun, how do we know these lengths of these three sides are going to be a length of a triangle? Anybody remember this? That would be if it's a right triangle. That'd be exactly right if it's a right triangle. We are talking about oblique now, okay? So there's one check you had to do to make sure that three sides of a triangle will make a triangle. That's angles. Sides, lengths of sides. If y'all remember this, I'd be impressed because they briefly talk about it in geometry and they don't ever talk about it again. Basically, the idea is this. If I add two sides up, any two sides, they have to be greater than the other side. Y'all remember this? If you add any two sides up, and of course it has to be every combination of that. So 10 plus 7 is 17, that's greater than 6. 6 plus 7 is 13, that's greater than 10. 10 plus 6 is 16, that's greater than 7. So these are lengths of triangles. Now, you get suspicious sometimes if you see something like this. And now you go through there and go like, okay, 6 plus 7 is 13. That's not greater than 15. So what would happen here, guys, is if we go into it and start diving into our formulas and start finding all the angles, you will get an error. You'll actually end up with, I want to say, the square root of some big number. And it won't work. Okay? So just saying, I mean, you don't have to do this every time. You don't have to check. But if you do get an error when you're talking about cosine, which will very rarely happen, but if you do, it's because the lengths of the sides are not good enough to make a triangle. You've made one side too long to where the other side can't connect to it. Okay? But in this case, that works, so we'll go ahead and dive into this. And let's go ahead and figure out, again, I recommend starting the smallest one first, but who cares? But let's just go and do the smallest one first for this one. I'll use the equation. So again, once you fill in the equation, guys, you notice we're looking for an angle here. When you're looking for an angle, we have to do what 1 and 3 was on warm-up. Okay? Which is 3 steps. I'll say 3 steps only. One is, move everything over that's positive. And then divide by what's attached to cosine. Morning. And when you do those 2 steps, guys, what do you notice is left on the right side of the equation? The only thing that's left is cosine of C. How do you find an angle? Inverse. Good. You notice this whole time, guys, I've not put anything in my calculator yet. We will save all calculator stuff to the very end. Move everything over. And the reason why I say this is because when you start doing this, you'll start dealing with some very large numbers. Easy way of doing typos, any way of confusing the calculator and yourself. So I just avoid the whole thing, move everything over, and then type it into the calculator very last. So, we found one angle. Angle C is 36.18. Sorry, I'm trying to get... All right. 36.18, right? Yeah. Yes, sir?
You mean to put it in C?
Oh, did I put it in B? I'm sorry. 36 point... Yeah, right? It's actually my Monday because I had yesterday off, so...
I think that's an ID10T.
You think it's an ID10T? Way to bottle up on that there, Johnny. You're just waiting for that to happen, huh? All right, so we go ahead and look at the next one. Now, we do have one of 2 options here. You can go and do law of sines here if you like, or you can still stick with law of cosines. So, we go through and say, all right, I'm going to go ahead and stick with law of cosines because we need to practice. So, I'm going to go ahead and find now side B. And so with side B, you end up having 6 and 10. Side B is 7. And so we go through our steps again, what we've always done, move over our positive numbers. And then divide by what's in front of the cosine. And again, at this point, you're left with cosine of b. In order to figure out any angle, you go ahead and take the inverse of it. Johnny, I assume you already got it done. So 7 squared minus 6 squared minus 10 squared over negative 2, 6, 10. And for the most part, guys, like I said, it always looks like the same type of equation, just different numbers. Here we go. C done. B is now done. What do we do for the last one? I would totally do that. I would not do any more formulas. So, when you end up with that, your angle A ends up being 100.29. Does that take care of the three unknowns in this triangle? All we needed was to find three angles. We found three angles and we're done. So again, like I've said before in this unit, a lot of work is to be done, but it's repetition work. It's repetition work. That's all it is. It's the same length over and over. So this would look the same every single time. From here, you can go in the law of sines or do law of cosines again if you need. Then from there, it's simply taking both of these answers and subtracting it from 180. However, be very careful in this scenario, guys, because what happens if I get that angle off by maybe 10? Let's say I do a typo in the calculator and I get off by 10. What happens if I use law of sines for angle B? So let's go through and say I got 46 here, right? Then I decide to avoid doing all of this work and going back to law of sines. So I have, what that means is, this becomes 46. And now I use law of sines here. So the sine of 46.18 over its corresponding side, which is 6, is equal to sine of B over 7. What's the problem there, guys? Sine of 46.8. Why is that a problem? Because it's not right. I'm using an answer that's incorrect to find new answers. So guess what happens to the rest of this triangle? It's all wrong. Everything's wrong. However, if you make the mistake here of putting 46.18, then you go over and do this. Do you use anything in your previous calculations for this middle answer? No, you don't. So that means you have a chance of getting that one right. Now, however, unfortunately, it will come over and bite you right there when you're finding the last angle. So just be cautious of using your answers for something else is what I'm trying to say. If you're using an answer to the next part of the problem, make sure that answer is absolutely correct, or to the best of your knowledge is correct. If not, guys, we could have easily done law of sines, law of cosines, this for all three angles if we wanted to. Best idea about that one is, yes, more work involved. However, you're not using previous answers to come up with that answer. Each of these sections is independent. Does that make sense? If you use law of cosines for each one. But there's more work involved. I understand that. However, you're bettering your chances of getting it right. Each one of these will be graded individually. Okay? And they'll be right or wrong. Okay? So make sure we're individual when those are looking at it and give yourself each individual a chance of getting it right. Okay? All right. That's my disclaimer for for that. All right, finally we get to the last one, which is the last thing talking about area. Now, interesting about the area with law of cosines. Again, it only works with one special case scenario, and that is where you're given all sides. If you're given all lengths of the sides, you can use, and it's those two formulas together. So you got to find this variable called S. S basically means add up all the lengths of the sides. So if I was to label this, find the perimeter. So S is equal to 10 plus 7 plus 12, and then divide it by 2. So you end up getting what? 1729 divided by 2. I'll just leave it like that. If it was 28, I'll put 14, but it's an odd number divided by an even number. Not going to happen. That's fine. Just leave it like that. Because basically, guys, the calculator is going to do the work anyways. So who cares what kind of a number it is? Leave it there. So then we go on to figure out what the area is. The area says take that value you just found, and now you have 4 things you're multiplying. S, and the distance from every side to that S. So it's 29.2 minus, what, 10? 29 over 2 minus 12. 29 over 2 minus 7. Requires a little bit extra typing, but that's all right. As long as the calculator's doing the work and I'm not doing it, I don't care. Minus 10. 29 over 2 minus 12. And you guys should be faster at this because you're better at texting than I am. So just go pretty quick for you guys. 7 is the last one. And you end up with 34.98. It is area, so your units are squared. That's it. Now, like I said, it's easy to see it now because we've separated each one of those individually, but when you go in to do your problems, if they give you all sides, you use this formula here. If they give you side, angle, side, you use the one that we begin the lesson with today on. Any questions about that one? Pretty straightforward. Again, be careful with finding S, guys, because you're using it to find your next equation. All right. So what we're going to do now is we'll do some problems out of the book. So partner up with anybody you want, and one partner grab a book, and the other two grab one piece of paper.